Hello and welcome in this series of webinars. Are you in the mood for better simulation educational? The global subject is clearly to talk about model-based system engineering with a focus on validation and verification of models. It's about simulation or model execution. My plan is to put a new presentation online each month with a dedicated angle. We will cover advanced topics beyond modeling. Indeed, the goal is to check that we deliver the correct artifacts out of our models. Why? Using a model tool to formalize and document requirements, trace them is clearly not enough. Other key questions may arise. What about verifying and validating them? Can SysML tools allow to produce industry-grade quality documents? The answer is yes. We'll see how very soon. Today, we will introduce this series of webinars. Then we'll make a very short review of MBSE and SysML. Then we'll speak about what are the possible expectations, some restrictions we might face, and how to deal with all this. We'll use an example, which is illustrated in my book, SysML in Action with Cameo Systems Modeler. This book will be available very soon in English and French, and most probably in Chinese as well, in hardcover and ebook format. Stay tuned. A few words about myself. I'm involved in modeling tools for several decades now, mainly focusing in embedded systems domains, avionics, transportation, automotive, and so on. My current position is independent consultant, delivering trainings and consulting for system engineering purpose, using my strong experience promoting tools such as StateMate, Rhapsody, Artisan Studio, and so on. MBSE is my core skill, with a large expertise in SysML. In the next slide, we'll talk about the content of the webinars. Then some introduction about system engineering and model-based system engineering. What do we mean with model? Which kind of standard is used? We'll mention the main associations group of people dealing with MBSE. The screen dumps used in this webinar series are based on the no magic SysML tool Cameo Systems Modeler, which also includes great simulation features. No demo will be shown. Nevertheless, part of the model used will be available for download on the No Magic website dedicated URL. Feel free to ask for it. This is the link you may want to use for this purpose. The main idea is to go further in using the MBSE approach. One key area is in validating the models. In other words, ensure the model will be understood as we wanted it to. This is all about communication, and communication is, or it should, working in both directions, from the stakeholders or the customer to the suppliers through a number of documents. Some MBSE artifacts will be integrated in those documents in order to have a more precise specification description. One could say more formal. And please, don't assume building a simulation setup needs a software engineering skill. Well, it can help, sure, but we'll demystify this as efficiently as possible. Also, you may think simulating will overload your work, and it will. But in the system engineering domain, we all know delivering requirements poorly validated will cost at the end of the project many dollars or euros. And also, a model, if its syntax has a minimum level of formalism, can be executed. It can handle links, such as traceability, verification and validation, so on. SysML has been adopted about 10 years ago, leading a good maturity from the tools supporting this language. One of the key artifacts out of a model is the ability to generate documents out of the models. Using model is definitely a good way to improve communication, but this communication is still based on contractual documents. Therefore, it appears the quality of those documents relies obviously on the quality of our models. In order to ensure good quality, validating models, meaning executing them, is way to go. The goal is to get those models as close as possible from your user needs. Next, just recently, the International Organization for Standardization, ISO, has made SysML an ISO standard, endorsing works from the Object Management Group, OMG, and the International Council on System Engineering, being COSI. So, basically, what can we expect from simulating models? The best way is to summarize with this definition, which is key to me, based on my own experience in the field. We want to achieve requirements validation, and this is all about it, ensuring properties of those requirements such as clear, precise, etc. MBSE with SysML is a great way to review scenario-based descriptions. We all know requirements are divided in several categories, one of them being the functional part, both existing in the domain of the problem and the domain of the solution. Models are good for simulating such requirements, where real-time constraints can be specified, but without the concrete pieces of hardware and software to be addressed in the solution domain. It's quite difficult to validate them yet. What about restriction? While we see great values brought by simulation, we'll still have to have in mind the limits of the area. First, these limits come from the SysML language itself, as it's focusing, at least for its behavioral part, on discrete kind of systems. Obviously, some subsystems are more dealing with the continuous principle. The SysML language can bridge those two complementary worlds thanks to the parametric diagram. SysML tools can interpret with continuous or called mathematical or business, electronics, mechanics, and so forth, specialized languages and tools such as Modelica or even VHDL to some extent. Using such business models, we need to be very careful not to enter too much in the solution domain. So, building executable models can require different skills compared to writing requirements. Well, this is my challenge to convince you it's worth spending some time up front in order to save many time and money in the later stages. Not all tools can support the same way simulation. In this series, we'll focus on Cameo Systems Modeler, but here I can give a few words about other tools such as Rhapsody or PTC Integrity using a different technology. For summarizing the two main possibilities to execute a model, I will talk about one tool I was a supporter of more than 2 decades ago, StateMate from iLogix, now IBM Rational. This tool seems to be still available, actually, and can simulate models using interpreted mode with great features such as step back, indeterminism detection, etc. And compile mode in order to generate prototypes and speed up validation and verification. Well, now with the current power processing of computers and memory resources, speeding up is not really needed anymore. So let's benefit from interpreted mode advantages and get rid of drawback from compile mode, requesting to install a compiler to deal with errors. As for generating code, the model needs to be complete enough, quite difficult tasks for a system engineer indeed. For interpreted mode, it can be as it is, incomplete and with errors, no problem. In order to get our models executable, what are the traps, the drawbacks? Actually, the most common issue one can see is that we are human beings, and a human being loves to be as close to perfection as possible, or indeed what he thinks the perfection is. And what he thinks might be different from what users need. Then ideas are coming, we want to fix issues, prevent from wrong behavior, and so on. And I saw that so many times. It leads to get a monster model, a monster, so huge and most of the time not readable. Not readable means often poorly executable too. But this is not the biggest issue. The real threat is to enter into solution domain too early. And also, I'm sure you faced the following. People are concluding, getting an executable model to run simulation is time consuming. I have enough time to spend and this is up to software people to produce code, not my business. Well, all wrong. Using poorly validated requirements will lead to bad products, and even more bad products wrongly tested. It leads to a disaster, pretty sure, and the artifacts produced from this model will or should be used as a reference by software and test people, for instance. Last, when writing requirements, the goal is to describe what to do and not how. The model should only include elements relevant for getting our specification. And here we have to be more precise. The system model. That means we will have other models. The environment, sometimes called plant, model, the test cases model, and so on. All those models can be in the same repository or not. This is a matter of project activity and processes, management decisions. They just need to be isolated in some way. Are we only testing them? No. Testing is only one technique for validation. But as for verification, test cases will be used all along the V cycle if we use it. Prototyping is also an interesting technique to improve communication or to discover some aspects we are struggling to apprehend. Scenarios execution, finally, is a good way to validate requirements. What do I mean with positive domain? To me, this is what we want to get, but for safety people in safety critical projects, they want not only the system to be the right one, as all stakeholders, they also want to ensure the system won't do what we don't want. In other words, prevent some unwelcome scenarios to appear, leading to a product out of control and behavior which has not been tested. This list is related to Cameo Systems Modeler. We will summarize among the 9 diagrams what can be executed. For requirements, it is possible to pass the requirements textual description based on a specific glossary in the tool in order to get constraints for simulation. The goal is to check the verify traceability link between requirements, most of the time imported from a repository, to model elements. As for use case, they are not really formal, so simulation can be tricky. Use case scenarios can be textual description, but they can also be modeled using sequence diagrams. And sequence diagrams can be executed both to stimulate input values, but also to be generated as an execution trace from the simulation or even drive it. Well, simulating packages is not really possible, but useful to set up our simulation configurations. Block definition. As part of the static part of SysML model, there is no value in trying to simulate them, but the dynamic part behind each block is interesting, of course. Operation, activities, state machines, to name a few. BDD is our architecture. As for IBD, an interesting feature of Cameo Systems Modeler is to animate ports to follow flows and other signals exchanges through those ports between parts, for instance. The parametrics will be used as constraints both with an integrated subset of mathematical language in Cameo or using an interface to third-party tool able to run math algorithms more efficiently, such as Modelica, for instance. State machines are very powerful means to describe the dynamic part of a model. In interpreted mode, Cameo is using a technology from the W3C consortium based on XML language dedicated to state charts. The former name of state machine as David RL created them. Features include back animation for current and visited states, path used or transition executed. We'll see nice pictures later. The OMG has developed FUML, standing for Foundational Subset for Executable UML Models, for executing activity diagrams. So activity diagrams included in SysML models can be executed too. We have seen today what kind of models can be used to achieve requirements validation. This is done by using a system model which includes only requirements-related elements. An environment model to close the loop. This will be the topic of one of our next webinars. A testing model, also a coming webinar. And for all that, first you have to decide the global objective of modeling this project. On top of this, and even before going to simulation, this is highly recommended to run static checks, named validation in the diagram editors of Cameo, to avoid conflict of misuse of elements and their relationships. Again, my challenge and goal for this series of webinars is to promote requirements checking through MBSE, to cover only requirements and only requirements. Extra elements or features should be located outside the system model, and this is key to my speech. Next month, we will enter into some more details for getting executable models, what is possible, where to be cautious, and an example. Thank you very much for attending. Feel free to reach me by email for more information. olivier.cast.consulting@gmail.com. Very soon I have the great pleasure to announce the availability of my book around November, so just before Christmas, both in French and English. You can already find its reference on a number of selling websites by typing SysML in action with Cameo Systems Modeler. Goodbye and see you soon.